Yes, it's really a great opportunity, and I would like to call Isabelle Pinzauti Babrzynski to say a few words about that, and also the role of IBMA that really had in this meeting.
Thanks a lot, Dr. Marinculić. Thank you very much. On behalf of IBMA, the Biocontrol Manufacturers Association, I'm very glad to welcome all of you to the 12th event co-organized by the long-lasting partnership between Pan-Europe and IBMA, this time with the lead of the Biofili Association in Croatia, and showing that integrated pest management works for farmers and ensures food security. It is more than 10 years that we show the importance of integrated pest management, IPM, based on an holistic approach, starting with agronomic measures, working with nature and ecosystem, and then forecasting system, mechanical, physical control, and of course also biological control. Showing it works already for many farmers, allowing to use chemicals only as a very last resort. Thank you to our chair and main organizer of this event, Dr. Marinculić, the Zagreb Veterinary Faculty. Thanks to all the participants for being here, and of course to all speakers. And thank you for your support to the member of the European Parliament, Ivan Vilibor Sinčić. So just a few words more. Our members, the Biocontrol Manufacturers, are really keen to provide biological control solutions for farmers, so that farmers can continue to progress while supporting biodiversity and soil health for an agroecological transition. Many solutions are already used and effective, as we will see today, while many more may become available in the future. In fact, we just released a biological control pipeline report showing that biological control plant protection products submitted by 2028 will cover 28 million hectares, of which 23 million hectares are arable crops in Europe, plus 10% more potential for the invertebrate biocontrol agents. So what do we need? All of us need a sustainable use regulation that will help achieve this potential by giving legal standing to biocontrol, enabling regulatory actions for fast approval, with a legal definition and a positive target for biocontrol, as well as a strong hierarchical IPM definition. As I talked about it before, the EU will have the legal muscles to mainstream the transition to environmentally friendly farming, working with nature. Finally, it is important to underline that many farmers will reduce pesticide use only when they are confident of the availability and efficacy of biological control solutions. Biocontrol, together with all the practices and methods I mentioned before, is used on millions of hectares worldwide. Efficacy is clear. Availability is now the problem, and the sustainable use regulation is the solution. Moreover, for all of us working on this topic since so many years, the SUR is essential for the transition to sustainable and regenerative agriculture. I wish to all of you a very fruitful conference and discussions.
Isabelle, this is the moment of the Executive Director, Martin Dermine. Hello.
Thank you very much, Professor. Yes, thank you everybody for taking part in this very important conference. I wanted to thank also my colleagues from IBMA and from Biofili for co-organizing this event. I also take the opportunity to publicly wish a happy birthday to Isabelle Pinzauti today. And yes, this event I think is really important because we need to have a science-based discussion around pesticides. We hear a lot of information in the public arena around pesticides, the fact that we cannot do without, but we have many scientific evidence. We have scientists who constantly work on making it a reality to reduce the use of pesticides and also work without pesticides. So I think this conference is very important, and I also wish to particularly thank my colleague Natalia for all the efforts she put in the organization of this event. And as I will be speaking later, I will stop now. Thank you very much.
Well, at this moment, I would like to ask the technical assistance, because we have a video from the European Parliament, a Croatian guy, Vilibor Sinčić.
Dragi dame i gospodo, čast mi je pozdraviti vas sve ispred Europskog parlamenta. Ja sam Vilibor Sinčić, član Europskog parlamenta iz Republike Hrvatske. Član sam Odbora za zaštitu okoliša, javno zdravlje i sigurnost hrane. Kao što znate, zastupnici Europskog parlamenta intenzivno rade na usvajanju novih standarda, kojima se stvaraju preduvjeti za očuvanje i zaštitu okoliša, proizvodnju hrane uzgojene na ekološki način i edukaciju svog stanovništva u smjeru održivog života. Proces je spor, te se na samom putu susrećemo s nizom problema, otpora, nerazumijevanja i lobiranja. Pesticidi su bili dio kemijske revolucije prošlog stoljeća. Donijeli su poljoprivrednicima razna rješenja, ali tada nitko nije mario za ekotoksikologiju i štetan utjecaj. Danas smo pametniji i učimo na vlastitim greškama. Zajedničkim djelovanjem kreiran je zeleni plan. Taj zeleni plan je strategija koja nam daje niz ciljeva, a neki jesu smanjenje upotrebe pesticida na 50% i povećanje ekološke poljoprivrede na 25% do 2030. godine. Ti ciljevi pred nas sve ovdje stavljaju zadatak da pokažemo i dokažemo da je to moguće. Imamo jednu veliku priliku pred nama i zbog nas i zbog naše djece moramo je iskoristiti. Sinergija je ključna riječ. Sinergija svih nas biofila daje veliku priliku za razvoj poljoprivrede bez pesticida. Imamo znanja na koji način smanjiti uporabu pesticida te razviti zamjenska rješenja. Napomenuo sam riječ sinergija, što znači zajedničko djelovanje gdje se multiplicira snaga i efekt. Vjerujem da ćemo pronaći kvalitetan put koji će promijeniti svijet kakav smo dobili u nasljeđe prema boljoj budućnosti. Drago mi je da se ovakav skup održava u našoj Hrvatskoj, koja treba veliki poticaj da mijenja svoje ustaljene prakse i način razmišljanja. Poljoprivreda je naša velika mogućnost za kvalitetni razvoj, koji je sada u lošem stanju. No, veseli me da svake godine vidim male pomake na bolje. U teškim uvjetima poslovanja naša eko-gospodarstva postaju sve brojnija. Imamo naznake da se počinju stvarati organizirani lanci otkupa, što će dodatno stvoriti potražnju za ekohranom, a samim time i dodatno dati poticaj bržem i kvalitetnijem razvoju ekosegmenta. Pošto put od 1000 km započinje prvim korakom, mi smo hrabro zajedno svi već zakoračili na taj put i ništa nas neće zaustaviti na njemu i ostvarenju naših zacrtanih ciljeva. A to je naravno proizvodnja hrane bez otrova. Želim vam na početku ovog skupa čestitati na velikom dijelu koje svi zajedno činite za sve nas. Želim da vaši radovi budu plodonosni. Ovim putem sve vas još jednom pozdravljam. Hvala.
At this moment, I would like to call Master Josip Kraljičković, actually the head of the Department of Agriculture and Forestry of the Zagrebačka County, just to say a few words about that, because we are really proud that they accepted the patronage for this meeting.
Thank you. Hvala lijepo. Pozdrav svima. Ja ću govoriti na hrvatski. Rekao profesor da mogu. Nama je drago da se ova konferencija održava i da smo mi pokrovitelji i da je udruga koja je organizator konferencije na sjedištem u Zagrebačkoj županiji u općini Jakovlje. Mi smo u Zagrebačkoj županiji prepoznali važnost ekološke, organske proizvodnje hrane na način da smo i na razini skupštine donijeli dokumente kako razvijati tu organsku proizvodnju.
So, greetings to everyone. We are pleased that this conference is taking place today and that we are the patrons of this conference. We at the Zagreb County have recognized the value of organic production, food production, and we have therefore adopted certain documents at the level of our county assembly that will favor such production.
I prepared my speech in English, but not. Zagrebačka županija, možda za uvod, je treća po broju stanovnika u Hrvatskoj, a šesta po veličini površine. Držimo da smo potencijalima za poljoprivredu i za ukupni razvoj smo prva županija u Hrvatskoj i zbog blizine Zagreba i zbog blizine svih institucija koje mogu doprinijeti ukupnom razvoju i ukupnom životu. Tako držimo da imamo i zadaću da iskoračimo u odnosu na ostale i da budemo napredniji, bolji i brži od drugih županija, evo budemo tako neskromni.
So we, the Zagreb County, are the third county when it comes to the number, to the population, and the sixth county when it comes to our surface area, the size of the county itself. That means that our potential for agriculture is the greatest in all of Croatia. We hold the first place in that respect, both due to the vicinity of the city of Zagreb and also due to the vicinity of all the institutions. Therefore, we have to use this advantage in order to make a step forward with respect to all our counties.
Naša skupština, naš parlament je donio program razvoja ekološke poljoprivrede 2030. godine, znači dokument koji piše da vizija je županije da bude vodeća zelena županija koja svoj razvoj temelji na razvoju organske i inovativne proizvodnje hrane i razvoju pametnih sela.
So, our assembly adopted a program on the development of agriculture up until the year 2030, and our vision is to become the leading green county in Croatia that will have organic and innovative production of food and will develop villages.
U programu, da bi to ostvarili u viziju, imamo 3 strateška cilja. Prvi je da do 2030. 100% površina bude pod ekološkim uzgojem u županiji. Drugi je da sve naše škole, vrtići, sav javni sektor, tako kažemo, da se koristi isključivo hrana organski proizvedena. I treći cilj, da se na našim turizmima, ugostiteljstvima nudi organski meni, organska hrana također. Su to 3 cilja koja su usmjerena, da kažemo, prema potrošačima ili prema onima koji bi trebali pripomoći razvoju.
We also have 3 strategic goals. The first one is to develop to transform the entire agriculture of the county into organic agriculture up until the year 2030. The second one is that all schools, kindergartens, the entire public sector uses food that is exclusively organically produced. And the third one is that our tourism also relies on organic food and organic menus.
Program ima 16 mjera koje su ukupno vrijedne oko 40 milijuna eura do 2030. godine. Mi te mjere provodimo već i ovoj godini i lanjske godine na način da smo raspisali javne pozive i svi naši ekološki proizvođači i oni koji to jesu i koji to žele biti mogu ostvariti pravo na potporu sa intenzitetom od 70%, a maksimalno 20.000 eura godišnje.
We have 16 measures in order to reach our goals and have at our disposal a total of 40 million euros up until 2030. We have already started implementing certain measures this year and the year before, and we have launched certain public calls that invite various entities to apply for subsidies in the maximum amount of 20,000 euros per entity. That is 80% of funds may be provided.
Mi želimo da Hrvatska bude ambicioznija u smislu organske proizvodnje, da budemo vodeći u Europskoj uniji, jer mi to možemo, mi to moramo, mi smo biser u toj Europskoj uniji i ako se zadovoljavamo prosjekom, onda nismo pravi europejci, jer nemamo pravog usmjerenja ili dovoljno dobro vodstvo. To je moje osobno mišljenje, a to smo potvrdili ovim našim programom.
Our ambition is that Croatia become the leader in the EU when it comes to organic or ecological production. We can achieve this if we have our goals in mind, and we can be the leading organic production country in the EU. We mustn't be satisfied with just an average. We have to want the best.
I se nadam da će ova konferencija pripomoći, evo, da sve ohrabrimo da možemo i da moramo biti bolji. I evo, ja na samom koncu predajem taj program kojega možete vi na našoj stranici županijsku pronaći. Ovdje je hrvatska verzija našem predsjedniku i ovdje je sažetak na engleskom, tako da to možete koristiti i promovirati dalje drugima. Također se evo zahvaljujem na pozornosti i otvaram na ovaj način da želim da konferencija bude uspješna. Ovu konferenciju otvorenom Croatia without pesticides. Mislim da to reći. Hvala lijepo.
We hope that this conference will help all of us in achieving these goals. We therefore want to give you our program and our strategy, both in Croatian and in English, a summary in English. We thank you for your attention and we wish you a successful conference.
Thank you, Master Krajicković. And we are really proud that actually we have the same path. We as an association, as well also with all our partners, and also the Zagrebačka County. So I hope that I will live such a short time just to see these results. There's a nice legend of Peruvian tribe, Quechua tribe, and it goes like this. There was a fire in the forest and all the animals escaped. Actually, the animals were really frightened about that, but one animal was very, very brave, and it was a hummingbird. And the hummingbird was actually flying and bringing drop by drop of water. Okay, everything's clear. So we are here, and let us be a big drop. And so the first part of our drop that we are planning to actually seize this problem is Executive Director of Pesticide Action Network, Martin Dermine. Thank you very much for accepting this role. And actually the stage is yours.
Thank you very much, Professor. I will try to share my screen. Okay, it seems to work. Can you see my presentation?
Yes, we can see your presentation.
Okay, I will put it in full screen. Yeah. Okay, good. Thank you very much. So I just want to say a few words on Pan-Europe. Pan-Europe is an old NGO founded in 1987. We have members across the EU, 2 members in Croatia, EarthTrack and EcoHvar. And our aim is to replace toxic pesticides with environmentally friendly alternatives in a scientific way. We are a team of scientists with also political science colleagues. And our focus is mainly on agriculture, agronomy, toxicology of pesticides, as well as water. And we also have a campaign running to have towns pesticide free. We do awareness raising, lobbying in the EU and national institutions. And we also carry out some legal actions to get the most toxic pesticides banned in priority. We are a small team of 12 staff. And I wanted to highlight that the issue of pesticides is not something new, but that there was clearly a very increase in the speed of both the scientific publications linked to the harm of pesticides on human health and the environment, but also of the publications of very important international bodies, such as the Intergovernmental Panel on Climate Change, which published a report on agriculture in 2019, The same year, we had also two other groundbreaking reports on agriculture. One is from the IBMA, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, as well as the FAO report on the state of the biodiversity for food and agriculture. These reports were published by 3 different groups of scientists, but their conclusion is all the same. We are going in the right direction if we want our food systems and agricultural systems to be sustainable, to be able to cope with climate change, with droughts and so on, and floods. We need to completely change the system and to go towards agroecological practices, to reduce the intensivity of our systems, to reduce the use of synthetic fertilizers, the use of pesticides, to reduce animal breeding as well, and to increase the share of plant-based proteins in our diet. In the same vein, the scientific community is working more and more on the impact of pesticides on health and the environment. And there I just put 2 examples that I think that are really very self-explanatory. This quite famous now Hallmann study in Germany, showing that over 30 years there was a decline in 75% of insects. So insects can, of course, be crop pests, but many insects are natural predators of the crop pests, and they are also a source of nutrition for birds that also contribute to crop protection. And the second publication in France from 2018 showing a dramatic decline in bird populations in farmland for farmland species, and it's up to 95% decline over 35 years for certain species, which is extremely worrying. There is a myth that we still find very much among some regulatory authorities, that there is a possibility to have a safe use of pesticides. We hear it very much from the pesticide industry, but we also hear it from a series of public servants, which is very worrying, because it is completely contradicted by the breadth of scientific evidence, showing that even when you carry out agriculture in a, let's say, responsible way, when a farmer is respectful to all the limitations and the rules to apply pesticides, the pesticides are not controllable. They move into the environment, bystanders are exposed, they move in the soil, they move outside of the soil, outside of the field, and they do have negative consequences, even when farmers use them in a responsible way. And the first victims of the use of pesticides are farmers themselves. There are scientific publications pointing at the impact on their health, on that of their children, on birth malformations among their children, cancers, increased rates of certain types of cancers, among them the endocrine-related cancers. Also, the use of pesticide has an impact on bystanders. We can find very high rates of pesticide residues in house dusts in the houses of bystanders. So these people are clearly, and in particular the farmers, the first victims of this system. We also find pesticide residues in food. Regulatory authorities keep saying, yes, but they are safe. I would say they are safe from a regulatory perspective, but what we observe at Pan-Europe is that very regularly the European Commission is decreasing the maximum residue allowed in food, because with new scientific evidence, pesticides at a certain amount in our food that was considered safe for 20 years, suddenly a new evidence shows any rate 20 years, and that they have to be cut by 5 or 10 sometimes, which is a big difference. At EU level, the phasing out of the most toxic substances is quite slow because of the slowness of the regulatory procedure, because of delays in member states, in the Commission to reassess the pesticides. So there is an urgent need to reduce them in parallel. And yesterday there was an interesting conference in the European Parliament where a scientific director from the French Agronomic Research Institute, INRAE, indicated that if we don't do anything by 2050, there will be no single effective pesticide, synthetic pesticide on the market, because gradually resistance is occurring among pests. And since 1994, no new class of synthetic pesticide was created. And one of the reasons is clearly because they do not pass the regulatory system and they are very often too toxic. Among the civil society with whom we work a lot, there is a very strong demand for a paradigm change in agriculture. In the EU, there is an instrument called the European Citizen Initiative that allows citizens to express themselves and to make specific demands to the Commission. Out of only 7 successful initiatives since 2011, already 2 of them are anti-pesticides citizens initiative. Also in the frame of the recent Conference on the Future of Europe, citizens very clearly expressed their will to reduce significantly the use of pesticides. And every year the Commission publishes Eurobarometers where citizens also express their concern about the presence of pesticide in food. There are regularly protests. Here, both of them on this screen are against the neonicotinoids pesticides to protect pollinators. Sorry, there's a problem here. Okay, so the politicians do realize that there is a problem. It takes a lot of time to address it. In 2009, there was the publication of a directive on the sustainable use of pesticides. And in theory, with this directive, farmers and public authorities were supposed to reduce pesticides. But what we saw in the EU is that in many countries, the use of pesticides have strongly increased since 2009. So there are several reports pointing at the complete failure of this directive by non-implementation at member states level. And in 2019, with the EU elections, the Commission came up with its EU Green Deal and developed a series of policies, among them the farm to fork and biodiversity strategies, as well as the chemical strategy for sustainability. All of them mention pesticides and mention food systems to make them more virtuous. And the Commission, following the farm to fork and biodiversity strategies, has published in June last year a new proposal for a regulation on the sustainable use of pesticides. Contrary to a directive, a regulation must directly be applied and implemented by regulatory authorities and by citizens. So it's much more stronger than the previous directive. And the most important proposal in this regulation is to cut by half the use and risk of pesticides until 2030, which from a political point of view is quite ambitious, to make integrated pest management mandatory in a very strict way. Farmers always say, we already do IPM, but then when you go into the details, it's a very light IPM that do not allow for a strict reduction of pesticides. And another important part of the proposal is to reduce pesticide in sensitive areas to protect citizens' health. In cities, we already have some good examples of cities who already ban pesticides like glyphosate to maintain the cities. It works very well, but also to protect the environment and the quality of our water. I will finish with this pyramid that we have developed jointly with IBMA and IOBC, which is the International Organization for Biocontrol. I like it very much. You saw it also in the background of Isabelle from IBMA. It is a pyramid explaining what we consider that a scientific IPM is, which starts with prevention, fertility, having healthy soil to have healthy crops, and do all we can to prevent like, for instance, long-term crop rotation, the use of resistant varieties, and so on. Then the next layer is using monitoring tools, forecasting tools, warning systems to avoid using pesticides. Even if there's some level of pests in the crop, we can tolerate some damage before using pesticides, because pesticides are also expensive. Then enhancing natural control by planting hedges, by planting some flowering strips to attract beneficial insects and what is called functional biodiversity. Then the biocontrol, as we will hear today, to put ourselves voluntarily additional biocontrol in the field. And then finally, so all this is what is happening and allowed in organic. And then the tip of the pyramid is the use of chemical control as a last resort, as it is mandatory normally under IPM. So I wish you really a very pleasant conference. I think we will hear a lot of very interesting information, and I also wanted to thank all the speakers for accepting to take part in this conference. Thank you very much.
Thank you for this very informative and interesting lecture. And now we will continue with the biological control in perennial systems permanent plantation, and with Dr. Lieselot van der Wecken, an IBMA consultant and also the founder of Proterra Agro. The stage is yours, Lieselot. Perfect.
You can see and hear everything?
Yes.
Okay. Yeah, okay, perfect. Thank you for the invitation to talk about perennial systems. Perennial systems by far are more interesting systems to actually elaborate agroecological principles, because they give you time to actually develop the agroecological systems, and you can develop them as it were an ecological forest or a more natural system. What do we do at Proterra Agro? Proterra Agro was founded almost 5 years ago. The idea of Proterra Agro, because of care for our planet, people, and generations to come. As Martin stated it so nicely, we have a duty towards future generations in terms of sustainability. What we try to do day to day is to facilitate this transition towards sustainable or even regenerative production system, which results then in resilient systems that are less, let's say, dependent on all the agro inputs, the chemical at least, trying to diminish that as much as possible. And with the help of biological control, we can facilitate this transition. Content of my presentation, the soil as a living organism, how to build or rebuild soil, the importance of living soil for plant health and human health, our plant health pyramid and crop resistance, and then examples of beneficial organisms and disease management. Felix Wäckers later on will then take for his account the pests and above ground challenges. So soil It's often neglected in our cropping system that soil is a living organism. There is billions of organisms living together in a soil that actually makes the soil function in the ecosystem. Today we've got used, at least in Western Europe, to see organic matter levels of 2%, which is actually dysfunctional soils. The proof is there because there is regenerative farmers that can turn this around and are already up to 10 to 12% organic matter. A big part of this organic matter comes from necromass, meaning dead microbial life, which is then stabilized in micro aggregates, which is actually a very sustainable form of sequestering our carbon back into the soil. Our conventional systems after Second World War had been a lot of tillage and chemical pesticides, which has actually resulted in a reduction of soil life. The good news today, and that's what I want to bring, is that soil life can be regenerated. A very simple, let's say, drawing or concept is photosynthesis. Up till a few years ago, I always focused on the above part, like we often do, is that plants provide us with oxygen and take CO2 out of the air. What we have to know or really understand is that up to 70% of the photosynthetic products go via the roots as exudates and actually serve there as food for our soil microbial web. And so the bigger part actually is feeding the soil life to be able to enter into a symbiosis with a lot of those microorganisms so that the plant can have, just like us in our gut, have an intelligent exchange system for nutrients. More and more publications today also state that our gut, like the healthy probiotics in our gut that actually are an insurance for our good human health. The same happens with plants and soil. If a plant is around his roots surrounded with a lot of microbial life, this is an intelligent system to make sure that this plant gets the nutrition, not only the macro, but also the micronutrients, to become a strong resistant plant. And these two are linked because, of course, we eat the plants, and we will see that food from these kinds of living soils will also improve human health. So what we can say in these two systems, the microbial interface of nutrient solubilization and providing humans with nutrients and plants with nutrients is key. Microbial life is key in this. It's not only me that started thinking about this a long time ago, but there is actually people working with this and getting great results in big acreages in our big North American farms, where they see that we can build our plant up to a level that this plant is even resistant to pests and diseases. The first step or the basis of this pyramid is to have a complete photosynthesis. So the plant functions well and all the metabolites related to that are well formed. In a second level of health, we have complete protein synthesis. In a third level, there is the lipid synthesis. And in a fourth, extremely well managed level of plant health, you see plant secondary metabolites that actually make those plants resistant to pests and diseases. So there is actually really literally a bottom-up approach to health, which we have to make sure our soils are healthy and biodiverse in microbial life to help our plants along in this process to become more resilient to any pest or disease attacking them. This goes together with this nice IBMA IPM triangle. It's not only IBMA, it's also PEN and IOBC, as mentioned with Martin. Thank you for elaborating on that. I don't have to go into much detail. The bottom line here is that the vast fundament, the big chunk of this triangle is actually all the cultural and biological measurements we can take in our cropping system. Also thinking or rethinking some of our cropping designs, combining crops that actually can be synergistic both in soil life and in helping each other out in other with other challenges. What are those organisms? And I say our beneficial soil organisms is intelligent crop nutrition, or enables intelligent crop nutrition and protection. This intelligence lies in that there is a plant microbial signaling, root exudates of plants attracting the microbial life it needs, and the microbial with their volatiles also signaling towards the plant. Having this microbial interface means that you actually make sure that your plants get out of your soil what they need to become to grow well and to become healthy. One of those, and that's a very exceptional one, are the arbuscular mycorrhizal fungi. And it's a fungi living inside of the root zones. We both have ecto and endo. The endo mycorrhiza, they have intracellular structures which actually they exchange the carbon of the plant with phosphorus from the fungus. A lot of soils have enough of phosphorus available, but it's not available, bioavailable for the plant. It's there, but it's not in such a form present that the plant can take it up. What is the nice thing about this arbuscular mycorrhizal fungi, that's why I start with it, is they form an extra-radical network, which is actually a physical extension of your root nutrient exchange zone, times 500. So you can imagine a plant with this next figure standing there without mycorrhiza, actually depleting a part of our root zone. When they have mycorrhizal fungi and our extra radical hyphae, you can see they extend outside of this depletion zone. The fungus develops further, and actually you can see them as a network for nutrients that then go back to the plant. These extra radical hyphae work just like the roots in exudating our carbon, so feeding our soil microbial life. That's a big advantage. That zone expands. And the other way around, you can see it as a highway for nutrients for the plant in helping them take up. That's why I say that they are the internet and the FedEx of the soil, because these extra radical hyphae actually connect all the plants within your system. So that means that nutrient and water repartition can actually be established, resulting in a much more resilient system. We have done some trials, of course, on that and seen that we have a huge gain in all kinds of macro and micronutrients, also carbon sequestration within the plant tissue. It was a simple trial where we actually had plants with and without the mycorrhiza, and then we analyzed the plant tissue, and we saw this usually in carbon. That means that photosynthesis is much more efficient and carbon is sequestered much better in the plant. Imagine reinstalling those mycorrhizal networks on a large scale in agriculture. What a gain this would be also in carbon sequestration. This is a view of the plant without in the control, and with the mycorrhiza. You can see it by the naked eye. I think it doesn't require further explanation. If we think about also the salts that are today applied on our fields to feed our plants, which I actually often say, yeah, we're putting Baxters into our plants rather than feeding our soil and making sure that the intelligent system I talked about earlier is activated so that plants can take up what they really need. We are now today putting salts on our fields, actually also killing off our microbial life. We can see that also this microbial life has a big impact in the better accumulation of NPKs and a whole range of micronutrients. This is huge, I think, huge increases. That means that today we are by far not efficient in managing our nutrition. If we take it to an agro-ecosystem level, that means plants together, we should be starting to think about plant diversity and how this results in below and above ground ecosystem functions. So think about what you want to grow, which ecosystem services you need to grow this, and start thinking about combinations. I'm not, again, the first one to think about this. A nice book for gardening and for orchards is already out there. Not one book, there are several books. You select your plants based on your below and above ground ecosystem services, and they can then offer early support, for example, of your pollinator in an orchard, beneficial insects and mites, hosting them, nitrogen. In the same way, we can think about nutrients, nitrogen fixing, phosphorus, potassium, all kinds of synergies that occur when plants are put together into a field. This is examples of these interaction where banana monocropping were intercropped with beans, and they're together with mycorrhizal fungi and rhizobacteria to manage the plant parasitic nematodes with a good success. So this is a tropical example because that's where I work more often, which allows me, these tropical areas actually allow me to go faster and see rapid results. Coming back to our systems, some examples of disease management in conventional production systems with the chemical agro inputs based, we have a strong reduced soil biodiversity where these disease and pests starts to prevail because there is no one to counter them, or they become even virulent where they are actually latent available in the soil. They become virulent under the pressure of systemic chemicals. Successful approaches for difficult diseases, completely agree, Phytophthora, it's not a piece of cake. So far in tropical contexts, we have been able to lower the disease inoculum and then filling the niche with beneficial soil organisms like Bacillus and Pseudomonas trichoderma. And then together with some companion planting and optimizing plant nutrition, we've been able to actually manage pretty well the Phytophthora, which is a very difficult disease to manage in our today's systems. The same with foliar diseases. Examples, of course, there is first the base of our pyramid, water and crop ventilation. That might mean think about your wind orientation, prevalent wind direction and row orientation. Irrigation, meaning dripping irrigation or micro sprayers rather than the big sprayers that wet all the leaf surface. The nutrition, key has been here the nitrogen management, where we have seen fantastic results with azospirillum, which is a free-living nitrogen fixing bacteria. By including that into the soil, our pressure in big foliar diseases in tropical crops has been going down tremendously, meaning that the workers of the plantation actually came to see me to talk about it. So it was really a very nice result of including again soil microbiology and nitrogen not entering our plant as unfinished amino acids, because amino acids as such are not digestible by our pests or diseases, or at least not so attractive as when they enter as urea or nitrates. The same with silicium and calcium, then adding those or making sure they get this through mycorrhizal fungi or other organisms to fortify our cell walls. Also, of course, a whole range of biocontrol agents are there, or to, let's say, prime our plants or to counteract our fungal foliar diseases. I always say then there is a bit of a dead end to our chemical eradication strategy today in our orchards. The very clear examples is citrus HLB, Fusarium tropical race 4 in banana, which is actually a very scary disease for our banana growers because it has eradicated another variety, Gros Michel, in the 70s. That was a tropical race 1. And we have our olives and xylella, so all vascular diseases that actually these pathogens that live into the vascular system of our plants, which makes it great cases to actually inject biologicals, or sometimes a lowering of our fungal or bacterial load, so of our pathogen, a lowering of our pathogen pressure by using injection of biological and or mineral, colloidal minerals, and then adjusting the nutritional scheme. As you can see, here is a citrus tree. Usually HLB, they say, yeah, just chop it because nothing can be done. Yes, things can be done, and there is proof out there that it can be done. You don't have to chop our trees, but we have to restore our soil balance and our nutritional, and first lower with biological control agents by injection or by mineral injections, our disease pressure, and then reinforce our plant to take up its own resistance. Same with the Xylella fastidiosa. An example, 1 year later, this tree was looking like this. So something can be done. And that's happy for us that we can actually go further than the dead end, or at least make a 180 degrees U-turn from an eradication strategy to a strategy that is actually conducive to life, and where we take all the tools from nature to actually make our crop production systems work. Another one I was talking about is the tropical race 4, where we saw that with the right microbiology, our roots were protected from a very invasive vascular fungus that actually results in dying off of the plants and not use of the fields for 20 years due to fungal inoculum. Also in field conditions, you can see the black plastic where it has been eradicated due to fusarium infestations. These marginal lands around the perimeter of the black plastics are managed with mycorrhizal fungi and trichoderma, and the phone calls with the technicians were really hopeful in the sense that he said, finally, our farmers have a reason to use biology for their soils. We see a 70 or 80% reduction of our disease severity, which means also in these very big challenges, biology is the way to return this and to recover again our cropping systems. Just to conclude, soil life is a fundament to successful perennial cropping system, as is the above ground biodiversity for the growth promotion, disease resistance, and it results in system resilience and sustainability, and ecological, social, and economical sustainability, because what we see is our farmer doesn't need to use each year more of its inputs. No, actually he becomes less and less dependent of our biological inputs, and you see that there is a bigger margin for farmers in the end. So what I want to conclude with is that proof of successful regenerative production systems is growing. There are very nice, clear examples, and I think it's time for us to really think and act and to develop resilient agro ecosystems that are conducive to life, that contribute to regenerate biodiversity, soil fertility, and cyclical processes in plant growth. The ones we have been lost in the Green Revolution, and that today also affects our planetary health. Thank you for your attention.
Thank you. Everyone Wäckers for revealing all these secrets. It's very, very interesting. And we will continue now, and we'll go to Professor Felix Wäckers with the biological control alternatives to pesticides in crop farming. So the stage is yours, Professor Wäckers.
Thank you, Professor. Let me share my screen. So do you see the screen? Is it visible?
Yes, we see it and we hear you.
Okay, good. So yeah, I will, after the nice presentations we've heard already, I will continue on what is already possible with regard to alternatives to the use of pesticides in arable farming. And just to reiterate a bit why the use of chemical controls should really only be used as a last resort, because if you frequently use chemical control, pesticides are commonly used to control pests, and they are can be effective in that on the short term. But they not only kill the pests, but they also kill the beneficial insects in the ecosystem. So that includes pollinators, but also those beneficial insects that normally provide natural pest control. And by eliminating those beneficial insects, what we see is that you get pest resurgence. So the pest is no longer suppressed by their natural enemies, and we get increased pest problems after pesticides have been used, which means that the farmers then will have to use even more pesticides, which we've also heard, the more pesticides you use, the more resistance pressure you generate. And as a result of the resistance, the pests are no longer as affected by the pesticides, and you have to use even more pesticides. So actually, this creates a negative spiral, and to break this negative spiral, we really need to go and use integrated pest management. And this triangle, this pyramid, we've seen already in a number of presentations, and I think it's important to highlight it again. It's the IPM triangle, as was developed by Pesticide Action Network together with IBMA. It's based on earlier IPM systems that actually go back to the end of the 50s. So IPM is not a novel concept. But what we also heard is that even though IPM has been around for more than 70 years, it's still only weakly implemented. And if we look at the response to the Sustainable Use Directive, where IPM has been identified as a crucial element, we see that IPM is commonly used in orchard systems and in greenhouse production systems, but in arable and field crops, it's really marginal, its use. One thing that we see is that monitoring, for instance, is hardly being used in arable farming at all. And if you don't monitor and you don't work with damage thresholds, it means you have no idea what your pest pressure is in your field, and you then have to take care of or use chemical pest control to control the pests. If they are really there or not, people use this chemical control preventatively. What I want to present today is a few examples of how this can be changed. One is by looking at the landscape management in a way that supports natural pest control, the natural regulation that occurs in the field anyway, and the use of biological pest control, meaning releases of natural enemies in this particular example. As I said, what we see in most arable farming system is a preventative use of pesticides. And for many people, that sounds like a normal thing to be doing. But if you look at this cartoon here, it shows you that a preventative action is really an counterintuitive and not a very conductive way of controlling pests. Not only if you apply pesticides when there's no pests around, the use of the pesticides is a waste of time and money, but these pesticides also have a negative impact on the ecosystem in general. So you actually undermine the ecosystem. If we look at the ways that pesticides are being used preventatively, we can see that a lot of farmers still use seed coating, which means that you apply a systemic pesticide, which will be then around for the whole cropping season. So you apply it whether there's pest pressure or not. Then often farmers use what is called calendar spraying, so they don't do the monitoring, but they just go out on a regular basis to apply pesticides. Or they spray upon a first pest record, which can be a pest record in the wider area, and not looking at thresholds.
Professor Wäckers,
Yeah.
excuse me to interrupt you. On my screen, your slides are not moving since the beginning.
Oh, that is unfortunate.
I don't know if I'm the only one. I suppose not.
No, then
Yes,
I'm
on
going
our
to-
slides
Yeah.
we can see it also.
You can see it on or not?
We
No,
can
the
see it,
slides
but
aren't
it's on the
moving.
first slide. So you should move it along with there is arrows down on your presentation. So you have to move it along with you.
Maybe you are not in full screen mode or did not choose the right.
I'm going to share again. So do you?
Yes, now
see
it is the IPM triangle slide.
Okay, the IPM triangle. I'm going to. And does it move now?
No, it's still the IPM.
Okay, so I don't know what the
And if you
problem
put it in presentation mode,
is. It is in presentation mode.
oh, now it's moving. Yes.
Now it's moving. So I will do it in this mode then, which is not optimal, but at least then you see the slides. Yeah, so what I was saying that what farmers tend to do is preventative use of pesticides, seed coating, calendar spraying, or spraying when there's the first record of a pest without actually looking at the damage thresholds. If you not use damage thresholds, the problem is that you not only use pesticides when there's no pest present, but you do kill all the natural enemies that are present in your system. And these natural enemies represent a value. They represent the value because they actually provide ecosystem services to the farmer. And the farmer is often not aware of the fact that these natural enemies are present and what value they represent. And we, as an industry, we sell these natural enemies for use in certain cropping systems. So we can actually tell you what the value of these natural enemies are. And if you look at a hectare of arable land, then we see that we usually tend to have about 20,000 parasitic wasps that attack aphids. And if you were to buy them, that costs you about 500 euros. There's 5,000 ladybirds in there. That would cost you 700 euros if you need to release them. There's hoverflies and there's lacewings. And altogether, if you add this up, the natural capital that is present in the 1 hectare of land equals more than 3,000 euros per hectare. By using pesticides when they are not required, so by calendar spraying, the farmer is actually burning this natural capital. So the natural enemies are being killed and cannot do the job of protecting the crop. Another way of doing pest control is actually trying to stimulate your natural enemies that are present in your crop. And you can do this by landscape management, in which you actually introduce hedgerows or flowering field margins. And by selecting these flowering field margins in a composition that are specifically targeted to biocontrol agents, we have been able to show that you actually increase your natural enemy populations. They then spill over into the crop next to the flower margin, suppress the pest there, which means there's less need for sprays, and that in itself contributes to natural pest control. It also has a positive effect on biodiversity overall. So the decline of insects, which we've heard about, can be counteracted by this as well. So this is something we've been doing for 25 years now, and I've been involved in a number of projects throughout Europe and in the US. And a good example is a project that we started in the Netherlands, in the Hoekse Waard, which is south of Rotterdam. It's an area where since 2004 we've introduced flowering field margins focused on natural pest control. And overall, there's now 500 kilometers of these flower margins present in this area. What this has been taken up by the farmers. They have created a farmer cooperative, and there's actually a waiting list of farmers to participate in this. It's really a big success. And what we've seen is that this has generated a 90% reduction in insecticide use by these conventional farmers in cereals and in potato crops. So this shows that by a targeted improvement of the agricultural landscape, you can actually generate considerable benefits in terms of pesticide reduction. And it looks much nicer as well. Here's some results that we collected at the beginning of this project, where we actually looked at aphid pressure over a 3-year period. And we see that both in potato and in wheat, the aphid numbers declined over time, and at the same time, the natural enemies, so the biocontrol agents naturally occurring, increased over time. Well, we've done these kind of projects in a number of countries. So I'm involved in projects in the UK, in Belgium, the Netherlands, in Germany, and Switzerland. And we've seen here, we always collect data in these projects. We work together with local farmers. They're directly involved. And we can show the farmers how these field flower margins work. You can see the blue bars here, the number of beneficial insects on the flower margins compared to a grass control margin. You see you have many more beneficial insects, biocontrol agents on the flower margins as on a grassy grass margin. Well, that's nice, but ultimately what the farmer wants is that these beneficial biocontrol insects also move into the crop. And that's something which we were able to demonstrate as well by doing detailed measurements in the crop, either next to the flower margin, next to the grass margin, or in the center of the field. And this graph here shows you the blue bars are the aphid numbers over time on these 3 locations. And you see that next to the flower margins, the aphid numbers don't go up over time, they actually go down. Whereas next to the grass margin, we see a clear increase in aphid numbers over time in the same field. And the explanation for this is that actually the black bar here, the parasitic wasps that attack these aphids, come in from the flower margin, and they obtain much higher levels next to the flower margin and in the center of the field than next to the grass margin. So this is clear evidence here showing that these flower margins spill over natural enemies into the crop. Ultimately, what the farmer is interested in is yield, and often we hear that these kind of approaches are good and well, but they are to the expense of the yield. So we looked at yield levels here in these trials also, and we were able to show that there is actually a yield premium by using these flower margins. So we in the case of the example that I showed you of the peas, we saw a 26% higher yield next to the flower margin as compared to the grass margin. And what is also nice in these data is that you see a clear decline with distance to the flower margin. So up here, this is the center of the field, 75 meters away from the flower margin. We still see that the yield is higher than next to the grass margin. Well, this is stimulating the natural enemies that are present in the crop already. Another way, another approach is, of course, releasing biocontrol agents, which is well known from protected crops, from greenhouse crops, but it can also be done in open field crops. And here is an example of a successful use of biocontrol agents. It's a little parasitic wasp, Trichogramma, which can be used to control caterpillar pests in, for instance, maize or corn. And these parasitic wasps attack the eggs of the corn borer, and as a result, the eggs don't hatch. There's no damage by the caterpillars, and this is an effective way of controlling this pest. And it's widely used in France, for instance, or in some other European countries, as well as in Brazil, where it's being used for sugar cane borer control. Another approach, which I think is very suitable for open field use, is the use of food supplements. In that case, we actually utilize the natural enemies that are present already in the crop, but we actually release food onto the crop that then attracts these natural enemies into the crop. And an example of these food supplements is, for instance, pollen here that can be dusted on the crop, and thereby the predatory mites or other biocontrol agents that utilize this pollen can be lured into the crop and can actually build up populations even in the absence of the pest. So we can actually increase the populations of the biocontrol agents before the pests arrive. And a good example where we have used this is a trial that we did in onion last year, where we worked with a conventional onion farmer who typically uses insecticides to control this onion thrips here. I asked the farmer to actually not spray in a corner of his field, and the rest of the field was being used with was being applied with pesticide. Then we looked at the natural enemies that are naturally occurring in this system. So we have lacewing eggs here, we have spiders, and we have a predatory thrips, so thrips that eats other thrips. And they were commonly found in the corner that was not being applied with pesticides. What we did in the corner that was not being treated, we actually dusted the pollen. We blew the pollen over the crop twice, and the rest of the field received 4 insecticide treatments, as the farmer would do normally. Well, this was the way it looked at the end of the cropping season. So you can see the part that received the 4 pesticide treatments is completely damaged by the thrips, whereas the corner that was not treated with the insecticides is still completely green. And that can be actually explained by the fact that the insecticides killed off the natural enemies. And as a result, you get these thrips resurgence that I mentioned before, whereas in the field that was actually dusted with the pollen, the natural enemies were stimulated, they controlled the thrips by themselves, and the crop looked much better at the end. So we also then looked at yield and in those 2 treatments, and there actually was a 15% increase in yield in the part of the crop that did not receive any pesticides. So this shows you that the use of ecological solutions does not have to go at the expense of yield, and that there are viable alternatives available that farmers can use and that can actually improve their yield and the economics of their system. Thank you for your attention, and I apologize for the fact that the presentation didn't work in the beginning.
Thank you, Dr. Felix Wäckers. Next, we have Davor Popović. Yes. Sure. Can you see the? Somebody. Can you see the presentation?
Yes, we can see it.
Okay, hello. My name is Davor Popović. Today my topic is an alternative to synthetic pesticides and fertilizers. I am working in company Biogeist in Croatia in Zagreb, and we can start.
Staviti vas da se vi vidite.
Okay. Few information about me. I am Master of Science in Agronomy. I am working in company Biogeist. I am husband, father of 3 children, entrepreneur, environmental conscious person, working in sales, research, personal application in agriculture, work with new technologies. In beginning, I need to explain what is pesticides, meaning of the word. The word pesticides comes from 2 Latin words. One is pestis, it means plague, pestilence. Other second word is sidere, means to kill, to suppress. So when we are talking about pesticides, these are products which we are using for control pests in agriculture. Pesticides themselves act on basis of active substance of active ingredients, which interrupts some psychochemical different processes within an organism and causes death. So when we are talking about pesticides, we are always thinking about that we need to kill something. They have high effectiveness, but there's on second side of the sword, they are very harmful on the environment and they have residues. So when we are talking about alternative to pesticides, the desirable alternative to pesticides would be products that which have good effectiveness, but which have no negative impact on environment and no residues. So we have a question: do such products exist? And answer is yes. When we are talking about products in organic for organic use, there is one group with name natural substances. This is very interesting group of products that offers us various solutions, and we know them under names of biostimulators or plant enhancers. So they create natural plant resistance, influence stronger growth and fruit quality. Its compositions are different, some various herbal compounds, vitamins, minerals, everything from plants and from nature. These products increase plant resistance to attacks by pests and diseases, but also to negative stressful conditions like drought, frost, mechanic damage, etc. So today in my presentation, I will try to give you some short information about two technologies which we have today in organic agriculture. And of course, these products are using in conventional agriculture. First group is vibro technology mineral activation. This is vibroactivated minerals. And second technology, it is technology of maceration of plant tissue. So let's start with first. The first is technologies vibroactivation of minerals. This is unique frequency technology that achieves crushing and energy activation of minerals at atomic level. So I used the word frequency. We need to know it's a frequency, it's energy. So we are using energy to crush minerals, these stones, which we have rocks around us in everywhere. Energetically activated and excited minerals have a greater ability to enter biological process. This is due to microscopic size. This tiny dust is 0.35 microns. This is 10 on -6. So you need to understand this is very, very tiny particles of minerals. And they enter directly into cells because they are so tiny, and they start various biochemical processes. So the plants, when we are using these products on plants, we are getting very good solutions, very good, for example, stimulates the growth of the plants and crops, so we have higher yields. It's increased the resistance to diseases and pests. We are talking about repellents. So in the next slide, I will talk about this. It reduced the use of artificial fertilizers and chemicals on plants. This is for conventional agriculture where they are using. Cultivation of healthier food with a lower content of residues and heavy metals, and it reduces water consumption. So first product which I need to explain from this vibroactivated minerals technology is with name vibrocalcite. This product is crushed rock. It's fine powder. We are using here nanotechnology, and this is 0.35 micrometers. Composition of this rock is calcite rock. So the main composition is calcium carbonate. Second is silicium oxide. And you know that these two compounds, calcium and silicium, are very, very important for stronger cell walls and membranes. So others are micro elements like magnesium, ferrium, mangan, selenium, which are very important for the normal development of the plants. Products is used 0.5% in concentration. Dosage this is 1.4 kilos per hectare. It is foliar application. It's every 15 days. And for me, the best characteristic of this product is it repels insects. So how it is repels insects? Because when we treat it on the surface of the plant, we are creating tiny film on the surface of the plant, and this tiny film is barrier. It's masked between plant and insect, and insects are confused, and they just cannot recognize plant as a target, and they move away and they don't attack our target in production. So we do not kill. We are using technology to camouflage our plants and to protect them. And I mentioned calcium and silicium, which they are making stronger cell walls and membranes in the plant tissue, and this prevents the spread of disease. I think that for example, disease cannot easily break walls of the cells and of tissue and spread in plant. This is second technology about I'm talking. It is herbal macerates. On Latin, maceration is coming from the word maceratio. It's mean wetting. Maceration is process of extraction of active substances from crushed herbs using a solvent. In this technique, we are using water as a solvent. When macerating medicinal and aromatic herbs, we extract various compounds which have various biochemical properties due to their actions. So positive actions, for example, are protection against pests and diseases, contact and systemic translocation actions. It's very interesting because we have here the word systemic translocation. It means that it can enter through the wall cells in a plant, and it's creating a protection field around the plant. And it's very important part. We have soil renewal and activation of positive soil microorganisms. So we are again with these products. We are working on that. We are using these products for life, developing our life in soil. So this is the first products, for example, which I need to explain. This is products for against the ground pests. Its name is mask product. It's name mask like camouflage something. It is a repellent. This is not insects for killing insects. It's just a repellent. Active substances are macerates of plants from the Eliaceae and Apiaceae plant families. Dosage is 1 to 2 kilos per 100 square meters. We're using it for land application by throwing on the surface, and then we have some tillage. We are inserting it in the soil, some 10-15 centimeters deep. These products work with smell. It repels soil pests like wireworms, elateridae, weevils, melonta, mole crickets, grill talpa, cutworms, agrotis, and snails. Today, in conventional agriculture, there is huge problem for find products which are protecting different crops against ground pests. And we have today organic product for such use, and it is interesting. Action period of this product is more than 4 months. So when we are using, for example, in production of potato, it is perfect time to defend the potato in the ground in period of hot period of the year. It's summer. This is the time when wireworms are attacking the potato in bigger quantities. So this product is using for us for defending it. For example, second product of these macerates, this is liquid product. It repels effects. Repels insects and pests from our culture. Dosage is 2 to 3 liters on 100 liters of water. We are spraying on the surface of the plants, and this smell of the products just reflects bugs, pests, and they don't attack our crops, and they don't creating new generations of insects in our crops. So, and these products work about 10 to 14 days. So when somebody's ask me, is this really possible that we don't need to use any more insecticides for killing? Yes, answer is yes, because we have new technologies in organic agriculture, so we have solutions. And this is my last slide. I need to explain some application in practice. All the mentioned products are used in cultivation and work effectively in practice today in the world. So when we are talking about vibro technology mineral activation, today in Croatia, producers for potatoes are using them. For example, in olive for olive fly for Bacteria ole, and for example in Australia in which avocado, for example, avocado. So from different sides of the world, this technology started to use, and other products are maceration technology. For example, companies like Arico from Netherlands, which are producing potatoes, seed potato, they're using in their production. For example, RVA, company for selling of seed of different crops like corn, are using for their for protection of corn of seeds. For example, for that birds don't attack young plants and don't pulling out. Way of protection is that this product is smelling to the bugs. Bugs like wireworms don't attack the root of the plants, and when birds come to that fields, they don't hear bugs that eating the root of the plants, and they don't pull it out. So we protect the plant. We're protecting damage from the pulling out of the young plants on the field with organic products. Everything today, every day we have more and more different technologies. I don't have lots of time of this presentation for explaining more beautiful technologies, and the positive side is that they are organic and they don't damage the nature. Thank you very much. This was all from me. If somebody have some question, he can contact me on these contacts. And I hope that we will make more and more solution for organic production in future. Thank you very much.
Thank you, Davor Popović. Now, next we have Lidija Gajski about adverse health effects of pesticides. Ще презентація. Имате USB, само. Можете USB.
Ви знаєте препознати мою презентацію?
Просто, имате USB, може само.
Вам дали, možda je tu rečeno mi da je to. Ne, to bilo.
So we have to find it on the USB.
Stiva, ti minute se mi zdravlje. Čak, ja ne strane, telefon i kamera. Su vaši posude. Da, ja to ne vidim. Ne vidim. A ništa da li smo zdravlje. Ne, PPT.
Možda možete prestati dijeliti zaslon dok ne nađete, da ne gledamo sve datoteke na stiku.
Dajte vratite. Biti pesticidi. Vratite. Koji su PPT i to. Pesticidi. Biti pesticidi. Dajte Prof.
I opet vidimo cijeli sadržaj stika.
Jeste vidi? Prezentacija.
Odlično, vidimo jako dobro.
Super.
Dobar dan. Hello. My name is Lidija Gajski. I'm a specialist in internal medicine. The topic of my lecture is health effects of pesticides on human health. I will proceed in Croatian. If
possible, please continue in English. Thank you.
I was told I
You have a translator here.
I will try, but I was told to prepare the lecture in Croatian, so I have it in Croatian.
Oh,
We have
I
a
apologize
translator
for
here
that. It
who can
was
translate.
agreed to be in English. I apologize for this, but it was agreed to have the first part strictly in English. So
Yes, we will
thank
have
you.
a translator translate on the end.
Pesticidi su, kao što znate, sve prisutni u okolišu i u ljudsko tijelo, ulaze kroz kožu, kroz oči, usta i kroz disni sustav. Brojna istraživanja dokazala su prisutnost pesticida u tijelu, u krvi, u većini ispitanika koji su ispitivani, u krvi, u urinu, u krvi pupkovine, što znači da prelaze u fetus, kao i u majčinom mlijeku.
Pesticides, as you all know, are omnipresent, and they enter the human body through various different channels: skin, eyes, digestive system, and such. Various research has proven the presence of pesticides in human body and in the human blood. In most of the respondents, it was proven to be existent in urine, in the umbilical blood, which means that it transfers onto the fetus and in the mother's milk.
Učinci koje će pesticidi proizvesti u tijelu ovise o prvo vrsti tvari, i to ne samo aktivne supstancije, nego čitave formulacije u kojoj se nekad nalaze i toksični adjuvansi. Treba uzeti u obzir i sinergijske toksične reakcije u slučaju mješavina, a i razgradnih produkata. Najopasnijima za zdravlje smatraju se insekticidi i to klorirani ugljikovodici, kakav je recimo DDT, danas većinom napušteni, no i dalje prisutni u okolišu i u ljudskim tijelima zbog akumulacije u masnom tkivu i prenošenju na potomstvo. Zatim su tu organofosfati i piretroidi, a od herbicida glifozat, već i činjenicom da je najupotrebljavaniji pesticid.
The effects on the human body primarily depend on the type of substance, the general formula overall, and also the toxic adjuvants. It also depends on the synergic effects of the toxic compounds, as well as the insecticides. For example, DDT, which has mostly been abandoned, but is still present in the environment, as well as in the fatty tissue of humans and such. We also have organophosphates, carbamates, pyretroids, and neuraminidase.
And glyphosate, which is the
the most widely spread glyphosate.
Dalje učinci u tijelu ovise o količini tvari i dužini ekspozicije. Najizloženiji su ljudi koji su profesionalno u dodiru s pesticidima, vidite koje su to grupacije, potom ljudi koji žive uz površine na kojima se pesticidi primjenjuju, hobi vrtlari i voćari, ljudi koji koriste pesticide u kući i konačno široka populacija najviše putem hrane, u prvom redu voća i povrća u kojem su prisutni ostaci pesticida.
These effects also depend on the not only the amount of the substance, but the time of exposition. And those who are mostly exposed are professionals working with these substances, people that live close to treated areas, those who use it at home, those who have hobbies in terms of gardening and growing different fruits and vegetables, people in the wider population due to exposure through food, water and air.
Učinci nadalje ovise o karakteristikama domaćina. Tu su razna individualna obilježja od kojih je posebno važna dob. Najosjetljivije vrijeme je prenatalno, znači embriji i fetusi, te djetinjstvo i mladost, i to zbog manje tjelesne težine i površine, veće osjetljivosti tkiva u razvoju i jer defekt mogu prenijeti na potomstvo.
Then we have the host characteristics as one of the elements that that impact the effect of pesticides. This is mostly personal characteristics, primarily age, especially in the prenatal period, then in childhood and in youth, especially because there is less body surface area and body weight, the sensitivity of growing tissue and developing tissue, and also the transferring to children.
O tome kako u tijelu pesticidi točno djeluju i kakve su im posljedice, naše znanje još uvijek ograničeno iz niza razloga koji su navedeni na slajdu. Ipak, količina znanstvenih nalaza raste i kombinacija istraživanja na staničnim kulturama, onih na laboratorijskim životinjama, opažanja u populacijama divljih životinja te epidemioloških studija s ljudima uz biološku plauzibilnost omogućuje povezivanje pesticida i patoloških stanja i stvara uporište za hipotezu o uzročnosti.
We still have limited knowledge on how pesticides truly work, but there is scientific evidence mostly done on increasing scientific evidence bases done through different analyses, and also in terms of combining the research and scientific work, which all brings into connection not only the causality but also the source of the issue.
No, it's about connecting the pesticides and diseases, which is quite proven, but also the magnitude of the research and the combinations of the research gave the opportunity for us to make a hypothesis about the causality. U ljudskom tijelu pesticidi djeluju na niz vitalnih funkcija i procesa. Na ovoj slici vidite učinak na staničnoj razini. Mijenjaju funkciju mitohondrija, recimo lijevo gore, stvarajući oksidativni stres, a time između ostalog upalne signale. U sredini je stres endoplazmatskog retikuluma koji vodi poremećaju degradacije proteina, uključujući one koje reguliraju staničnu smrt, kao i enzime, na primjer acetilkolinesterazu. Pesticidi remete membranske i ionske kanale, što se manifestira poremećenom živčanom vodljivošću. Ovo ljubičasto lijevo dolje je učinak na hormonske receptore, što je u podlozi endokrine disrupcije. Većina navedenog reflektira se na nukleinske kiseline, što znači genotoksičnost, ali i na epigenetiku, uključujući aktivaciju onkogena i potiskivanje gena koji inhibiraju nastanak tumora.
In the human body, the pesticides act on a series of vital functions and processes. In this picture, you can see the effects at the cellular level.
Okay, the rest is in English, so the audience, English-speaking audience will understand. Posljedica svega ovoga su poremećaji funkcija tkiva i organskih sustava, odnosno bolesti. One se mogu ispoljiti kao akutne i kronične.
The consequence of all of the above are various disruptions to the functions of the tissues and organic systems, that is, diseases, that they can reflect as acute and chronic.
Akutne intoksikacije i alergije nastaju nakon kratkotrajne izloženosti većoj količini aktivne tvari. Uz primjenu pesticida na farmama i okućnicama, boravak u blizini polja ili u prostoru gdje su netom korišteni i uz ingestiju, namjernu ili nenamjernu.
Acute intoxications and allergies are the result of short exposure to a greater quantity of active substances. For example, when pesticides are applied on farms and in the gardens, when people spend time near fields or in spaces where such pesticides have recently been used, and through ingestion, either intentional or unintentional.
Simptomatologija se kreće od blažih smetnji poput iritacije kože i očiju, preko proljeva i povraćanja, krvarenja u slučaju rodenticida, to su otrovi protiv glodavaca, do teških neuroloških i cirkulacijskih poremećaja, kome i smrti.
Symptoms vary from those mild ones such as skin irritations and eye irritations through diarrhea and vomiting, bleeding in case of rodenticides, that is pesticides against rodents, up to very grave neurologic and circulational disruptions, coma and death.
Procjena je da se svake godine širom svijeta dogodi 385 milijuna nenamjernih trovanja pesticidima, od čega većina u zemljama u razvoju. Evidentira se oko 11.000 smrti, smatra se da je stvarni broj značajno viši. Prevladavaju lakša trovanja, no i to je prema Svjetskoj zdravstvenoj organizaciji neprihvatljivo jer kumuliranjem može dovesti do težih oštećenja. U nas se zbog intoksikacije pesticidima godišnje hospitalizira 100-tinjak ljudi, najviše u zapadnoj Slavoniji.
It is estimated that around 385 million unintentional pesticide poisonings occur occur globally every year, most of which occur in developing countries. 11,000 deaths are recorded, and it is considered that the number of deaths is significantly higher. The most prevalent are less serious poisonings, but that is also, according to the World Health Organization, unacceptable because accumulation can lead to severe damage. In Croatia, due to pesticide intoxication, around 100 people are hospitalized every year, most of which in Western Slavonia.
Najčešća su akutna trovanja insekticidima. To potvrđuju i naši podaci, pri čemu su za najteža odgovorni organofosfati i karbamati.
The most frequent are acute poisonings by insecticides. This is also confirmed by our data. And the most serious are due to organophosphates and carbamates.
Organofosfati i karbamati su dnevni otrovi koji djeluju putem inhibicije enzima acetilkolin esteraze na živčanoj i živčano-mišićnoj sinapsi. To rezultira poremećajem provođenja impulsa s grčevima, paralizom, zatajenjem disanja i u kratkom roku može završiti fatalno.
These are nerve poisons that act by inhibiting the enzyme acetylcholinesterase on the nerve and nerve muscular synapses. This results by disruptions in the impulse, in the movement of impulse, with cramps, paralysis, and breathing hampering, and can result in death in a very short period of time.
2013. gotovo 100 stanovnika područja Rio Verde u Brazilu hospitalizirano je nakon što je poljoprivredni zrakoplov 20 minuta zaprašivao to područje insekticidom. 1999. polovina djece jednog peruanskog sela, njih 24, umrlo je nakon školskog obroka s mlijekom u prahu koje je bilo kontaminirano organofosfatom parationom.
In 2013, as many as 100 people living in the Rio Verde area in Brazil were hospitalized after an agricultural aircraft sprayed for 20 minutes the area with an insecticide. In 1999, half the children of one Peruvian village, 24 to be exact, died after having a school meal with milk, powdered milk that was contaminated by an organophosphate. In 2013,
2013 slično se dogodilo u indijskoj pokrajini Bihar, znači isto trovanje u školi zbog trovanja uljem zagađenim sličnim insekticidom.
A similar thing happened in 2013 in an Indian region, Bihar, because the children in school got poisoned with oil that was polluted with a similar insecticide.
Trovanja pesticidima mogu biti i namjerna. Između 110.000 i 160.000 ljudi godišnje počini samoubojstvo pesticidom, pretežno u ruralnim područjima. Prema Svjetskoj zdravstvenoj organizaciji od 60. godina do danas to je 14 milijuna ljudi. U Hrvatskoj je to drugi po redu način suicida iza vješanja.
Pesticide poisoning can also be intentional. Around 110 to 160,000 people a year commit suicide by using a pesticide, mostly in rural areas. According to the World Health Organization, some 14 million people have died in this manner from the 60s onwards. In Croatia, that is the second type of suicide after hanging committed here.
Toliko o akutnim trovanjima. Kronična ili opetovana izloženost pesticidima i u niskim dozama uzrokuje kronične poremećaje i bolesti. Dio njih ima u podlozi spomenutu blokadu acetilkolinesteraze. Drugi patomehanizam je štetno djelovanje na crijevni mikrobiom, crijevnu floru, koja, kao što je poznato, ima važnu ulogu u regulaciji probave i metabolizma, ali i imunosnog i središnjeg živčanog sustava.
On the other hand, we have chronic or repeated exposure to pesticides in low dosages, and this causes chronic disruptions and diseases. Some of them have at their basis the mentioned blockade of acetylcholinesterase. Another pathomechanism is the harmful effect on the intestinal microbiome, the intestinal flora, which, as is well known, plays a very important role in regulating digestion and metabolism, but also the immune system and the central nervous system.
Međutim, najveću pozornost u kontekstu patofiziologije kroničnih oštećenja privlači endokrina disrupcija. Endokrini disruptori ili hormonski otrovi vanjske su supstancije koje mijenjaju funkcije endokrinog sustava. Kako? Slični su prirodnim hormonima pa se vežu na hormonske receptore u ciljnim tkivima i mijenjaju, odnosno remete, normalni hormonski odgovor.
However, the greatest attention in the context of pathophysiology of chronic injuries is endocrine disruption. Endocrine disruptors or hormonal poisons are external substances that change the function of the endocrine system. In which way? Well, because they are similar to natural hormones, they get hooked, linked to hormone receptors in target tissues and change, that is, disrupt the normal hormone response.
Vidite koliko pesticida ima ili bi moglo imati ulogu endokrinih disruptora.
You can see the number of pesticides that have or might have the role of endocrine disruptors.
I na koje sve procese hormonski disruptori djeluju, od hipotalamusa i hipofize, preko jajnika, testisa, štitnjače, nadubrežne žlijezde i gušterače, do ciljnih tkiva. Riječ je o složenim, povezanim i višestrukim utjecajima.
And you can also see which processes are affected by these pesticides from hypothalamus and hypophysis,
Pituitary gland.
pituitary gland, thank you, pituitary gland, through ovaries, testices, thyroid gland, adrenal gland, and pancreas, up to various target tissue. These are all very complex, related, and multi-layered effects.
Ono što je posebno važno u vezi s hormonskim otrovima jest da štetno djeluju već u vrlo malim količinama, u dozama kontaminacije hrane, da je vremenski razmak između ekspozicije i manifestacije poremećaja dug, da su najosjetljiviji organizmi u razvoju, uključujući prenatalno razdoblje, što znači da se učinak vidi tek u drugom naraštaju. Što više, nekad čak u trećem i sljedećim generacijama. Klinički učinci DDT-a verificirani su u mladih žena čije su mu bake bile izložene. Slično je na laboratorijskim životinjama utvrđeno za glifozat. Povrh ovih posebnosti, koje djelovanje hormonskih otrova čine teško prepoznatljivim i podmuklim, zločudno je i to da im se učinak, između ostalog, manifestira na spolni razvoj i reprodukciju.
What is especially important in relation to these hormonal poisons is that their harmful effect is that they have harmful effects already in very small quantities, in dosages such as are present in contaminated food, and that the time period between the exposition and manifestation of the disruption is very long, and that the most sensitive organisms are those that are in development, including the prenatal period, which means that the effect can be seen in the second generation, or even more so, sometimes even in the third generation and in the later generations. Clinical effects of DDT have been verified in young women whose grandmothers were affected by DDT, came into contact with DDT, were exposed. Thank you. A similar thing can be seen on laboratory animals, and this is so in the case of glyphosate. In addition to all these specificities, which make the action of hormone poisons very hard to recognize and very subversive, they are also malignant in that the effect, among other things, manifests itself on reproductive health and sexual development.
U tom smislu izloženost pesticidima može dovesti do urođenih malformacija spolnih organa.
In that sense, exposure to pesticide can lead to congenital malformations of sexual organs,
do abnormalnosti spolnih žlijezda i poremećaja lučenja spolnih hormona,
to abnormalities of sexual glands and disruptions in the sexual hormone production.
I do smanjenja proizvodnje i disfunkcije spolnih stanica.
And reduction in the production and dysfunction of sexual cells.
Sve to rezultira kliničkim smetnjama i bolestima.
All this results in clinical disruptions and illnesses, diseases.
Slabljenjem libida i potencije, preranim pubertetom, kasnim početkom i poremećajem menstrualnog ciklusa, ranom menopauzom, a može dovesti do policikličnih jajnika, endometrioze, raka testisa.
All these leads to a weakened libido and potential, too early puberty, late start of the menstrual cycles and disruptions to the menstrual cycle, early menopause can lead to polycystic ovaries, endometriose, and testis cancer.
I dovode do patologije trudnoće,
and can lead to pregnancy pathology.
Vidite o kojem se poremećajima radi. I konačno dovode do smanjene plodnosti i steriliteta kako muškaraca, tako i žena.
And finally to reduced fertility and sterility of both men and women.
Svjetska zdravstvena organizacija endokrinu disrupciju smatra čimbenikom pada populacije, a moguće je da ima utjecaj i na trend smanjenja muške novorođenčadi vidljiv u zapadnim zemljama. Podaci su krajnje zabrinjavajući.
The World Health Organization sees endocrine disruption as a factor resulting in population decrease, and it is also possible that it affected that it is what caused the trend of decline in the number of male newborns in the overall population that is visible in Western countries. The data are very alarming.
Ova nova velika meta-analiza pokazala je da se između 1973. i 2018. broj spermatozoida u uzorku sperme na globalnoj razini smanjio za 62,3%, s tim da se u drugoj polovini tog razdoblja smanjuje dvostruko brže. Vidite ovdje i neke podatke za Dansku.
This new big meta-analysis has revealed that between 1973 and 2018, the number of spermatozoids in sperm samples at the global level decreased by 62.3%, and this decrease was twice as fast in the second half of this period. These are some of the data for Denmark.
Osim poremećaja spolne funkcije, endokrinom disrupcijom i drugim načinima, pesticidi uzrokuju i druge kronične bolesti.
Besides disrupting the sexual functions, endocrine disruption and other ways in which pesticides work cause other chronic diseases as well.
Izloženost muškaraca i žena prije začeća te trudnica može dovesti do urođenih malformacija djece. Osim spomenutih malformacija spolnih organa, tu su i druge, primjerice kongenitalne srčane greške, sve do teških nakaznosti kao što je prozencefalija.
Exposure of men and women before conception and of pregnant women can lead to congenital maldeformations of children. Besides the already mentioned maldeformations of sexual organs, there are other malformations such as those congenital heart failures up to and all other problems such as prosencephalia.
U indijskoj pokrajini Kasargod 25 godina nekontrolirano se zaprašivalo endosulfanom. Posljedica teške malformacije, mentalna retardacija, paraliza, sljepoća, gluhoća, neplodnost i maligne bolesti. Samo do 2011. 4270 potuđenih žrtava i više od 500 smrti.
In the Indian region of Kasargod, there was spraying with endosulfan done for 25 years in an uncontrolled manner, and the consequence of this are grave malformations, mental retardation, paralysis, blindness, deafness, infertility, and malignant diseases. Just until 2011, 4,270 persons were confirmed as victims, and there were more than 500 deaths.
U kratkom vremenskom razdoblju 2005. godine 300 žene na istom području SAD-a rodile teško malformiranu djecu. Sve su radile na poljoprivrednim površinama intenzivno tretiranim pesticidima. Južna Amerika područje je velike potrošnje pesticida, posebno glifozata. U Argentini je u populaciji poljoprivrednika 2 puta više urođenih anomalija i 3 puta više spontanih pobačaja od nacionalnog prosjeka.
In a short time period, in 2025, 3 women in the same area of the United States gave birth to children with severe malformations. All of them worked on agricultural areas that were treated intensively with pesticides. South America is a territory where pesticides are used very much, in particular glyphosate. In Argentina, the agricultural population has twice as many congenital anomalies and 3 times as many abortions than the national average.
Nadalje, pesticidi su dokazano neurotoksični. Poznato je da je neurorazvojna patologija u porastu i predstavlja sve veće društveno opterećenje.
Furthermore, it has been proven that pesticides are neurotoxic. It is well known that neurodevelopmental pathology is on the rise and represents a significant social burden.
Citiram, majčina izloženost pesticidima povećava rizik poremećaja iz autističnog spektra i ADHD-a u djece. ADHD to je poremećaj pažnje sa hiperaktivnošću. To je zaključak najnovije meta-analize studije iz raznih dijelova svijeta. Dakle, nedvojbena veza s autizmom. Radi se o insekticidima.
The exposure of the mother to pesticides increases the risk of malformations and diseases.
Not my, disorders,
thank you. Disorders from the autistic spectrum and ADHD in children. That is the conclusion of the latest meta-analysis that was conducted in various parts of the world. So there is a conclusive link with autism, and it is all due to insecticides.
Tu je i brojnim radovima dokazana veza sa slabijim intelektualnim sposobnostima, verbalnim izražavanjem, pamćenjem i motorikom, te s tremorom i poremećajima spavanja u djeci izloženih majki i djece izložene u djetinjstvu. Štetni neurološki učinci.
Numerous work also confirms a link to a weak, poor intellectual capacities, problems with verbal expression, memory and motorics, tremor and disorders, sleep disorders in children whose mothers were exposed to insecticides and in children that were exposed to insecticides in their childhood.
Štetni neurološki učinci povezuju se čak i s repelentima, insekticidima koji se nanose na kožu.
Harmful neurologic effects are even linked to repellents, that is insecticides that are put on skin.
U odraslih ljudi pesticidi se povezuju s blažim neurološkim poremećajima kao što su nesanica i oštećenje sluha, ali imamo i uvjerljive izvještaje o vezi pesticida i Parkinsonove bolesti.
In adults, pesticides are connected to less severe neurologic disorders such as sleep problems and hearing problems, but also we have conclusive reports on the links between pesticides and Parkinson's disease.
Ispričavam se, već smo prilično prekoračili vrijeme, pa bih vas zamolila ljubazno da zaključite predavanje. Jako je zanimljivo, ali jako smo puno prekoračili.
Da, evo preletit ću onda ja na engleskom do kraja. So it's about Parkinson's disease in the elderly. Then we have the connection between insecticides and glyphosate and dementia and Alzheimer's disease, amyotrophic lateral sclerosis, depression, and of course there's a connection with cancer. Some of the pesticides are forbidden because of their cancerogenic. No, but others like insecticides and glyphosate are still in the use in spite of being on the list of the International Agency for Research of Cancer as carcinogens. The most prominent connection is with the carcinoma of the breasts. It's about endocrine disruption. Then it's the cancer of the lungs. The connection is undoubtful. Tumors of the brain in both pesticide appliers and the children of the mothers who were exposed. Leukemia, both the elderly, the adults and the children. Lymphomas and Hodgkin's disease. This is the man who just won 78 million
damages
in damages because he was spraying Roundup glyphosate because he had acquired non-Hodgkin lymphoma, carcinoma of the kidney and the bladder, prostate, testes, ovaries, and uterus. Then there is a connection. This is pancreas, bowels, sarcoma of the bones, respiratory diseases, asthma, bronchitis, Then it's this is obesity and diseases of metabolism. A lot of research on the connection between pesticides and diabetes. Then atherosclerosis and cardiovascular disease, fatty liver disease, disturbance of the thyroid, kidney disease, autoimmune disease because pesticides damage the immunologic system. And here at the end, there is a table which shows the health effects of herbicides and then insecticides and fungicides. X are the diseases which are confirmed by the science. And it's enough, I think, for the conclusion that we have to try to avoid pesticides as we can, and that we have to fight on a systemic level for their ban. Thank you very much.
Thank you, Dr. Gajski, for this very interesting and with a lot of information lecture. And this moment there will be a small change in the program, and I would like to call Natalia Svrtan from Pesticide Action Network Europe, also a big assistance for this meeting. Thank you very much, Natalia, for everything. And so the title is Extension of Approval for Glyphosate. After Natalia, there will be Professor Valeria Vrček of Eco-Social Profile of Glyphosate.
Thank you very much. Thank you very much, Dr. Marinculić. Can you please confirm if you see my presentation?
Yes, we can see you.
Okay, thank you very much. So a warm welcome to all of you in the room, and warm greetings from Brussels. My name is Natalia Svrtan, and I'm a campaigner at the Pesticide Action Network Europe. And I also run a Croatian NGO, Zemljane Staze, which has the same goal as Pan-Europe, to reduce the pesticide use and to replace synthetic pesticides with practices who can eliminate the need to use synthetic pesticides. We conduct campaigning activities. We work closely with the European Commission, European Parliament, Council, then with the consumer health and environmental organizations on reducing the use of synthetic pesticides. Today, I will share with you a few information about the glyphosate approval process, because at the end of this year, another decision-making process will take place to decide whether we want or do not want glyphosate in our environment and in our food for the next 5 or 10 years. The global use of glyphosate increases constantly, and glyphosate accounts for 33% of EU herbicide market. So it was in November 2017 that member states voted, and they agreed to authorize glyphosate for the shorter 5 years period instead of 15 years. And later, the experts on mutagenicity revealed that decision-making process was based on the study sponsored by the industry, which was shown to be faulty and not reliable. In May 2019, the European Commission gave the mandate to 4 member states, France, Hungary, Sweden, and Netherlands, to do another assessment of the glyphosate. This was assessment group on glyphosate. And in June 2021, this group submitted the draft renewal assessment report to EFSA and ECHA. EFSA is European Food Safety Agency, and ECHA is European Chemicals Agency, and they concluded that glyphosate meets the approval criteria. Unfortunately, there was some several data gaps, and related to the behavior of glyphosate in the environment. And they warned the applicant that they need to clarify further these data gaps during the review process. In December 2021, EFSA and ECHA started public consultation, and Pesticide Action Network Europe submitted almost 200 scientific studies that provide evidence on ecotoxicity of glyphosate and glyphosate-based herbicides. And also many information from member state experts were received. Just please give me feedback. Do my slides go on, or are we still on the first slide? I guess
Works well.
Yeah, it's okay.
Okay, thank you for the feedback. And then it was last year in the May, where it was the 10th of May when EFSA announced that they will reschedule the publication of their expert opinion, which was scheduled for July 2022, and they postponed it for 1 year because they received a lot of material to assess, and for this reason they rescheduled the publication. And ECHA's committee for the risk assessment then decided not to classify glyphosate as a potential carcinogen or potentially genotoxic, even though the International Agency for the Research on Cancer in 2015 provided strong scientific evidence that glyphosate is potentially carcinogenic. And in September 2022, the updated risk assessment review was sent to EFSA. And in October last year, the Commission proposed that then approved glyphosate should be give another year of the approval. And even though some member states, Croatia included, voted against the prolongation, the qualified majority was not reached. And then again, the process was repeated in November. And as no qualified majority was reached, the Commission then had a legal right to prolong the authorization for another year. Pan-Europe strongly criticized this postponement because EFSA did receive enough evidence to quickly produce a statement that glyphosate actually poses an unacceptable risk to people's health and to the environment. And we expect that in July this year, EFSA will publish their expert opinion, and then we'll share it with member states, who will then discuss it at the SCOPAF committee, at the Standing Committee on Plants, Animals, Food and Feed. And then member states will again vote. So this is very important because glyphosate does not pose just impact to human health and to environment. It actually disrupt the natural balance. It affects soil, waters, and in the end causes significant financial losses that are not visible, but they are here. So as I mentioned, that previous EU decision was not based on the on independent scientific evidence, and there are also Monsanto papers. Dr. Gajski mentioned earlier Dwayne Johnson, who won 21 million case against Monsanto. These Monsanto papers are actually a set of documents that were released during this case, during this litigation. against the Monsanto company, and these papers revealed that Monsanto had ghost-written scientific papers. They deliberately hidden evidence that glyphosate causes cancer, and they have launched campaigns to discredit independent scientists. This should all be taken into account. Then there is strong scientific evidence that support the stopping use of glyphosate. Since glyphosate was classified by IARC, International Agency for Research on Cancer, as a probably carcinogenic to humans, there are also several independent studies that revealed the genotoxicity, and the Ramazzini Institute is working on global glyphosate study. These are all links you can click to find out more on this case. And Daniele Mandrioli, one of the researchers, stated that the results obtained in the global glyphosate study indicate the alteration of microbiome at the dose which is currently considered to be safe in the European Union, and also for children. So this is a very strong signal that we should think hard before we vote for another approval for glyphosate. These effects are also dependent on dose. The higher the dose is, the more detrimental are the effects. And there is also the question of coformulants found in glyphosate-based herbicides. Coformulants serve to enhance the efficiency and usability of products. They are, for example, anti-foaming agents, solvents, weighting agents, and the regulatory framework considers those to be biologically inactive to targeted harmful organisms. And in contrast to the declared active ingredients who are actually affecting targeted organisms. And added coformulants can take up to 50% of the formulation, so their effects should not be neglected. So there are strong evidence on the impact of glyphosate to waters. Even ECHA agrees that glyphosate is harmful to aquatic organisms, which in the end leads to losses in agriculture because of this imbalance and effect on bystanders and on organisms that were not targeted. So glyphosate also causes disruptions of nutrient and water uptake by the plant roots, which again leads to the increased occurrence of diseases, which leads to losses in agriculture and elimination of unwanted plants. I call them unwanted plants, not weeds, because I think that many of plants that are removed actually have their place in the ecosystem, and they're affecting the entire farmland. The birds, bees, butterflies, they're all affected. And also there is a strong scientific evidence that that glyphosate is toxic to bees. So I will share with you this presentation. So I will skip now for the sake of time. Alternatives. As I mentioned earlier, we need to redefine what weeds are. Not all plants that are not crops are detrimental and harmful. So we can consider the integrated weed management. This is also a link. You can click on it and find out more about integrated weed management, which is a project, Horizon 2020 project, with many stakeholders, experts, who is showing the different approach to weed management. Please take a look at this. This is very interesting and very useful. And also, please check on Pan-Europe. Here is a link to Pan-Europe website and report on the alternatives to weed management. In Croatia, Zemljane Staze Association prepared a translation of this report. Please check on our website. You will find all about the harmful impacts of glyphosate and about alternatives based on starting with agronomic practices. And there is also a petition that we started in Croatia. Please check this and please give your contribution, sign to send a strong signal to our decision makers that we do not want glyphosate in our environment and in our food. We are strongly backed up by the citizens, and this is our message to decision makers. We want pesticide-free Europe. Thank you for your time, and I wish you all a nice afternoon.
Thank you very much. Great lecture. Thanks a lot for everything. And let us continue with the glyphosate. Now we'll have Professor Valeria Vorcek from Pharmaceutical and Biochemical Faculty. Please sit.
Glyphosate. Glyphosate samo ovakve nove može ispod. Još jedan put. Sve ok. Nešto je zagađeno, ali pa rekli smo da to stavimo na ovaj efekt. Tu dolje ovaj tu. I sad njega dobro. Da, neću. Pa niste ga stavili na ovaj desktop? Ne znam tako, Marko, ne znam. Samo malo da vidim, možda je to negdje.
Ja sam sve na prezentaciju stavio tu dole.
Da, ali ja ne vidim glifosat.
Mislim da ste stavili.
Ne, pa posto su, rekli su da su stavili na desktop.
Mislim da je Bit Defender našao, Bit Defender,
Da, ne može otvoriti.
da treba, da to počisti, da treba pustiti da odredi posao. Može da izvučite pa ponovo stavite.
Da kopirate na kompjuter.
Ne može ući to.
Na kompjuter.
Ok, sad, kliknite na taj Bit Defender.
Sama.
Ne. Ako samo ovo da se bolje vidi, to.
Ok. Neki trajan.
Choose sam. Da, all items. Delete. Delete.
Continue.
Tu sad bi trebalo biti.
Ok, close. I sad ponovno. Još tamo. Znači.
Ja probati.
Mislim, nije mi bilo rečeno da stavim donesem stik, nego...
Sa stika, jeste?
Sa svih stikova sam stavio koje sam stavio. Sad ne možem da se pauza, mogu pogledati.
Na internetu. Vi napišite srce HR. Ponovo iskopčate srce HR. Pa se valjda neće vidjeti, no. Sad je to. Evo to. Želim mi izlagirati se van, to je poukovje. Dobro ne da otvori. Može. To se zove.
Can you see everything?
We can see everything very well.
Okay. Okay. So thank you for giving me an opportunity to discuss about one simple chemical, glyphosate, but my previous speakers already disclosed everything about this glyphosate. So there is no much left over for me. Luckily, I have only 8 slides, including the first slide. So I will be very short because we are running out of time. We shifted schedule, and so let me start. I'm a chemist, so I know only bad things about glyphosate, nothing good at the moment. It is already mentioned, but up there you see the official declaration from the Roundup, or this is Cidokor in Croatian. So you see maybe the name of the active ingredient, which is glyphosate. There's only 41% of it in a product, and other ingredients makes almost 60%. So Roundup is not glyphosate. Glyphosate is only an active principle, active ingredient in the formulation. So when we are discussing about toxic effects of glyphosate, or if we are talking about the environmental health effects of the glyphosate, it's not only glyphosate. It's a chemical mixture. So, for example, you see some of them: polyoxyethylene alkylamine, POEA, some surfactants, adjuvants, and of course undisclosed additives. So we should consider not glyphosate only, but all the product which is put on the field. We should talk about a new type of toxicology, which is we should consider the effect of chemical mixtures. In the old toxicology, the simple dogma is one substance, one effect, one dose, one effect. It's not that way. No man in the world, including you, is exposed to one chemical. We are all exposed to chemical cocktails, and this is what should be considered by a new toxicology. I say new toxicology because all people, I mean, most of scientists do avoid essays on chemical mixtures. Why? Very simple. It's expensive, it's time-consuming, and difficult to interpret. Maybe you've seen this scheme of the use of glyphosate starting from 1994 up to 2014. Okay, data should be updated, but be sure that we are using today
1 billion pounds of or kilograms of glyphosate all over the world. And you see this escalating trend. This is why we say glyphosate or Roundup or Cidocor is a high volume chemical and it is a blockbuster. And this is why the ingredients matter. Simply because we are not spraying on the field only glyphosate, but all other chemical, a spectrum of chemicals inside the commercial formulation. One example from the literature, paper of toxicology, a journal of toxicology. So this is polyoxyethylene alkyl amine, which is very important ingredient in a Roundup. And wherever is glyphosate, there is POEA. Just look at this short scheme, which tells you that, okay, the first bar, the black bar, is a control. These are some cell lines, okay, and this is some cytotoxic effect. So this is a control. The next bar is a glyphosate. Oh, it's quite almost no effect. And then you have a POEA, which has a large cytotoxic effect. And then you have a Roundup, which is all together. And you have an even larger effect in some cases. Some cell lines are affected more than individual chemicals. And the conclusion of the authors is pesticide formulations should be studied as mixtures, not as individual compounds for toxic effects. The next issue not resolved well and not answered well is what is the chemical fate of glyphosate? What is the environmental fate of glyphosate? And I just introduce here a sort of a network of different chemical pathways which do happen in the environment, in surface, groundwater, and soil. Some new metabolites emerge in the environment, and out of all, I will just extract one, which is AMPA or AMPA, which is amino-methylphosphonic acid. Wherever is glyphosate in the environment, there is also AMPA in the environment. You cannot separate them at all. They go together anywhere. So, in one paper from 2020, you see this AMPA compound. This is the main degradation product of glyphosate, has its own cytotoxic and environmental effects. It has a specific toxicological profile. Who does care about this? I mean, we are not talking anymore about the glyphosate. Of course, we have glyphosate all over the world. We have impregnated the nature with the glyphosate. And of course, I'll give you some data, should be updated, but numbers are even larger for sure. Let's say on the left, you see this Department of Agriculture, American one. You see the glyphosate and, of course, AMPA or MPA in 90 or 95 soy samples. So when you take soy, so of course it's a GMO soy, and then you will get also glyphosate and AMPA together with this crop. The next data coming from UK, so 25% of bread samples are contaminated by glyphosate. We can say sort of a message: no glyphosate, no bread, which is a sort of a failure of our culture. We cannot produce bread anymore without using synthetic chemicals. So it's not only about the toxicology, it's also about the culture. Of course, agriculture is culture. And on the right, you see the data from Germany, 2016. No beer on the market without some glyphosate residues. So no beer with no glyphosate. It's a civilization failure. So this is maybe I'm a wine drinker, not beer drinker. yeah, we are glyphosate-dependent society. That's true. And of course, we can say the next message, we pee what we eat. So this is from Journal of American Medical Association paper. You see the trend of glyphosate and AMPA in your urine. Of course, the similar should be in your blood. And if you follow this trend, you can maybe remember the first slide or the second slide, where you see the escalating trend of using glyphosate in the agriculture, and then you see the escalating trend of presence of the glyphosate and AMPA residues in your urine. Yeah, that's normal. We go from field to the fork or from field to the kitchen. Some conclusions. Just to repeat, glyphosate and AMPA are controversial, at least controversial in terms of safety and advantages. Ignoring risk, health risks, environmental risks, or whatever is against precautionary principle, which is a European principle, and we should stick to it. If you ignore all data on glyphosate, you are illiterate or immoral. Illiterate, that means you didn't read a lot, and immoral, it's an ethical consequence. No glyphosate, no GMO crops. That's interesting and maybe good news, because there is no reason to grow, I don't know, GMO corn or soy without glyphosate. I mean, the only trait of GMO crops is tolerance to glyphosate. So it's a nonsense. GMO with no glyphosate is a nonsense. And okay, my previous speaker, Natalia, were discussing about the political fate of glyphosate. And I'm just asking if GMO is behind the scene. Maybe we will get some answer later on. Thank you for this.
Thank you very much, Professor Vrček, for a very illustrative lecture. I think that we deserve a refreshment break now, so you're all welcome. Actually, everything's powered by Udruga Biofili Hrvatske. Yeah, so it's just in the hall. We'll have a break of 30 minutes. I mean, we can have it longer, but since we have an audience online, we have to be very precise.
So for the audience online, we will be back around 2:20. Until then, you can also take a break, have a coffee, snacks, and I'll see you soon again.